revise together gravitations. So what you have to bear in mind is that gravitation will only focus much on the forces of attraction exerted on the bodies in the universe, but specifically we are going to focus much into solving questions that comes under gravitation. So the first question reads: a remote sensing satellite of the Earth revolves in a circular orbit at the height of 250 kilometers above the Earth's surface. And then the first question they are saying, state the law of universal gravitation. So what you have to understand is that the law of universal gravitation states that the forces of attraction between two masses is direct proportion to the product of masses and inverse proportion to the square of their mean distance apart. So let's write that. So solutions. So that is 1a. It states that the forces of attraction between two masses is direct proportional to the product of masses and inversely proportional to the square of their mean distance apart. So this is our law of universal gravitation is stated. So some people they can use a formula to say the force is equals to the universal gravitational constant times the product of their masses, meaning mass of the Earth and mass of an object, divided by their mean distance, the square of their mean distance. So this is the law of gravitational constant when you want to state using the formula. So from there we can now proceed to question 2, where they are saying what is the period of revolution of the satellite. So what you have to bear in mind is this. Let me do this. So let's assume this is the Earth and then this is the Sun and then this is the planet. So if this planet is revolving around the Sun, there is a force that is pulling this planet toward the center, which is called centripetal force. Now this planet is moving under the influence of what? The force called gravitational force. So I'll do this. Gravitational force. Now let's equate this. So that is Fg is equals to Fc. So gravitational formula, that is universal gravitational constant multiplied by mass of the Earth and mass over the square of what? Their mean distance is equals to centripetal force, that is mv square over r. So this mass and that mass will cancel. Now, apart from that, we know to say that we are going to remain with g me, which is the mass of the earth, over r squared is equals to v squared over what? R. So from there, I'm going to cross multiply, and I'm going to have r times that is r g me is equals to r squared times that is v squared r squared. So that r is going to cancel that r. So I'm going to remain with the 1 r there. So I'm going to have g me is equals to v squared times r. So the reason why I'm doing this, because in most cases they bring questions to say derive the formula for what? For period, also for radius. So I have to show you all the procedures so that even if you have forgotten the formula, you can just follow this step to calculate. Now we know that velocity is equals to what? Distance over period. Now this planet was revolving around the Earth, making a full complete circle. Now the full complete circle is calculated by what? Circumference, and circumference is given by 2 pi r over what? Period. So this is circumference over period, which is the velocity. This simply means that where there is the velocity, I'm going to replace with the 2 pi r over t. So that is g me is equals to 2 pi r over t u square multiplied by what? R. So there you are going to get g me is equals to 2 to the power 2, that is 4 pi square r square times r over t square. So from there, that is g me is equals to 4 pi square r square times r, that is r cubed, over what? T square. So making t square the subject of the formula, I have to introduce 1 there and then cross multiply. So there, let me just have this part. So you're going to obtain t square g me is equals to 4 pi square r cubed. So there, divide both sides by g, mass of the earth, over g by mass of the earth. You cancel, you're going to have t square is equals to 4 pi square r cubed over 4, that is g, over g me. Square root both sides to get the value of what? T. So you cancel, that is t is equals to the square root of 2, the square root of 4 on top there, also the square root of what? Pi square, also the square root of what? R cubed, over the square root of g me. Meaning the square root of 4, that is 2. This square is going to cancel with that. I'm going to remain with pi multiplied by the square root of cube over the square root of what? g me. So from there, I'm going to proceed. Let me just grab this part. So from there, you are going to remain with tension or period, period is equals to 2 pi square root of r cubed over what? G mass of the earth. Now this, the formula that you have derived, that is the formula for calculating what? Period. Now, another thing that you have to bear in mind is that this radius is given by r is equals to radius of the earth plus height. So, we are not supposed to neglect what? The height that you have been given in the question. So, to include it, we are going to substitute radius with this. So, therefore, the final formula for calculating the period of the satellite is 2 pi square root of r e plus h cube root over g m e. So from there we can now start answering. So, question 2, we are being taught to calculate what? The period, which is given by this formula. Now, we need to convert this height into what? Meters. So, 250 kilometer over 1 multiplied by 1 kilometer is equivalent to what? 1,000 meter. So, that and that, they are going to cancel each other. So what are you going to obtain if you multiply 250 times 1000? That is 250,000. Leaving the answer in standard notation, that is 1, 2, 3, 4, 5. 2.5 times 10 to the power 5 meters. So this is the height that I'm going to replace there. So therefore, period is equals to 2 pi. So what is the radius of the earth? Radius of the earth is always constant. Also the mass of the earth and the universal gravitation is always constant. So what is the constant of radius of the earth?
6.37 times 10 to the power 6 meters.
So 6 point what?
37
times
10 to the power 6.
You are adding with what? See? The height. That is 2.5 times 10 power 5 meter cube over what is the gravitational constant? 6 point what?
6.673 times 10 to the power negative 11.
What about the mass of the earth?
5.98 times 10 to the power 24.
To the power 24. So if you punch everything on the calculator, everything, what is the final answer for period?
53.71 seconds.
53.71 seconds. No, so?
Yes.
So this was the required solution at T2. So apart from that, we can now proceed to the last question, where they are saying if the mass of the satellite is 1000, calculate its kinetic energy and the gravitational potential energy. So let me just start this part. From there, that is question 3. Kinetic energy is given by this formula, 1 over 2 mass velocity square. The mass is given, so we need or we have to calculate what? Velocity. Now, velocity, that is the orbital velocity. Now, how do you obtain the formula? So, same procedure, that is G, mass of the earth, m over r square is equal equals to mv square over r. So from there, what you are going to do is that this mass will cancel, also that will cancel, this radius will go, and that. You are going to remain with g, mass of the earth, over r is equals to v square, square root both sides. So rotational velocity is given by g, mass of the earth, over what? R. Now you have to bear in mind to say that this r is given by radius of the earth plus what? Height. So which is velocity is equals to square root of the universal gravitational constant, that is 6.67 times 10 to power negative 11. What is the constant mass of the earth?
That is 5.98 times 10 to the power 24.
The power 24 over r. So I'm going to replace r e plus h where there is r. So which is, what is the radius of the earth?
That is 6.37 times 10 to the power 6.
Power 6. And then the height, the one that we calculated,
The height
was 2.1, 2.5 times 10 to power what? To power 5 also. You are adding. So from there, if you simplify everything, what is your final velocity? Rotational velocity?
It's 3.01
3.01
times 10 to the power 16.
meters per second. So this is the velocity that I'm going to replace there. So therefore, let me now calculate what the kinetic energy. So kinetic energy is equals to 1 over 2, the mass that is 1000, velocity that is 3.01 times 10 to power 16 to power 2. So kinetic energy is equals to what? That is 1, that is 5. So what is the final answer for kinetic energy? So I think when calculating the velocity was supposed to be what?
7.7
7.76 times what?
times 10 to the power
3.
That's the second.
So if you punch everything, what was the final kinetic energy?
3.01 times 10 to the power 16.
To the power 16 joules. So this is the final answer for what? Kinetic energy. We made a mistake when punching, when obtaining the value for what? Velocity. So make sure you correct. The correct one is 7.76 times 10 to power 3. So from there, we are also being taught to calculate what gravitational potential energy. So gravitational potential energy is given by U is equals to negative G, mass of the earth, times what? Mass of an object over what? R. So from there, that is gravitational potential is equals to negative universal constant 6.67 times 10 to the power negative 11. Also, mass of the earth,
That is 5.98 times 10 to the power 24.
4. The mass that you have been given is 100 also. And then, what about the radius? The radius you are supposed to add also.
Yeah.
So, the radius of the earth, that is what? plus the height that was 2.5 times 10 to the power 5, right? So from there, after punching everything, what was the final gravitational potential energy?
Negative 6.02 times 10 to the power 10.
Negative 6 point what?
02 times 10 to the power 10 joules.
Times 10 to the power
10 joules.
joules. Always ensure to say energy is measured in what? Joules. Don't forget to put the SI unit. So if you have found this video interesting, don't forget to share, like, also comment, so that I'll be creating more content like this one. Thank you so much.